Hello friends, welcome to engineering tutorial. So today we are going to resume our discussion on electricity and magnetism. So far we have covered the basic concepts related to electric charge, Coulomb's law, about the theoretical concepts related to electric field, electric potential. We have discussed those things, and from numerical problems that discussion we have covered Coulomb's law, superposition principle and electric field. So from this video we will be discussing some numerical problems on electric dipole and parameters associated with electric dipole, such as dipole moment, electric field due to dipoles along the axial and equatorial line, dipole moment, then potential energy, torque and work done in rotating the dipole. So due to, in relation to these parameters we'll be discussing numerical problems. So this is the first question. So it is given that two charges, one plus 5 microcoulomb and another minus 5 microcoulomb are placed 1 millimeter apart. We have to calculate the dipole moment. So this is a question on electric dipole. As you can see, we have two charges. First one is minus 5 microcoulomb, and then we have plus 5 microcoulomb. So it is minus q, this is plus q, and then this is the center of the dipole, let's say, and they are placed 1 millimeter apart. So this is 2a, the dipole length, that is equal to 1 millimeter or 1 into 10 to the power minus 3 meter, and this is the charge. Now we know that the dipole length, that is equal to either charge, the magnitude of either charge, the value, and the dipole length, that is the value of dipole moment, the magnitude of dipole moment, and it is the direction of the dipole moment is from minus q to plus q, negative charge to positive charge. So very simply it will be 5 into 10 to the power minus 6 coulomb into 10 to the power minus 3 meters, that is equal to 5 into 10 to the power minus 9 coulomb meter. So that is the magnitude of dipole moment. Okay. So here is another question. So it is asked here is what is the magnitude of electric field intensity due to a dipole having a dipole moment of 2 into 10 to the power minus 8 coulomb meter at a point at a distance of 1 meter from the center of dipole, when the line joining the point to the center of dipole makes an angle of 60 degree with the dipole axis. So it is a very interesting question, because so far in the questions that we have discussed, the electric field intensity, we had to always calculate the electric field intensity at a point situated along the axial line or the equatorial line, but here it is different. So here it is given that we have a dipole, okay, this is the dipole, minus q plus q, this is the center of the dipole, and this is the separation distance. Nothing has been given about the charge magnitude or the separation distance. Only thing which is given is the dipole moment magnitude, is equal to q into 2a, and that is given 2 into 10 to the power minus 8 coulomb meter. We have to calculate the electric field intensity at this point, okay, and it is given that the line joining the midpoint and this point, it makes an angle of 60 degree with the dipole axis, that is the line joining the two opposite charges. So there is a formula here which is used to calculate the electric field intensity at any point situated in between the equatorial and axial line. So that formula is the electric field intensity is equal to magnitude 1 by 4 pi epsilon 0 magnitude of dipole moment, and this distance from the midpoint to that point, that is x, okay, this is x. So here 1 by 4 pi epsilon 0 p vector magnitude, that is the dipole moment magnitude, into 1 plus 3 cos square theta. Okay, so this will be equal to 9 into 10 to the power 9. The magnitude of dipole moment is equal to 2 into 10 to the power minus 8 by 1 cube. X is equal to 1. This gap, that is equal to 1 meter, because it is mentioned in the question that the line joining the point to the center of the dipole, it is at a distance of 1 meter. So x is equal to 1 meter, and the angle which the point, the line joining the point and the midpoint, it makes an angle of 60 degree with the dipole axis. So here it is 1 plus 3 cos 60 whole square plus 1. Okay, 1 plus 3 cos square theta, so this is 1 3 cos 60 whole square plus 1. So the value which is coming here is equal to 238, almost 238.1 something, so 238 Newton per coulomb or volt per meter. Okay, so this is the thing, and this is the important formula here which you should always remember, this formula. Okay, this formula is very important for determining the electric field intensity, the magnitude of electric field intensity at any point in space. So for that, these three data is very much required. First, the dipole moment, then the angle which the line joining the point and the midpoint of the dipole makes with the dipole axis, theta, okay, and then that length of the line joining the midpoint of the dipole and that particular point where we have to determine the electric field intensity, x. Okay, so this is the thing.